Good morning, everyone.
Good
Good
morning,
morning,
ma'am.
ma'am.
Good morning,
Good
ma'am.
morning, ma'am.
Okay, very good morning to all. Let's start. Last period we have learned about fractions. What we have learned about that fractions, just take a look about that. So I will share you my screen with you. In that screen, we are going to see what we have learned in previous period. Okay, we have learned about fractions. So what do you mean by fraction? Fraction is a part of a whole. Okay, fraction is a part of a whole, and a whole can be a region or a collection. And just a minute, let the open slideshow, then we will start. Okay, now here we have the slideshow about fractions. See, fractions 1. In that we have learned numerator upon denominator. What we have learned? Let's see. Here we have learned number of the form, that is numerator by denominator, are called fraction. Now what do you mean by denominator? Let's see that one. So denominator means what? The total number of equal parts a whole is divided into is called the denominator. Then what is the numerator? The number of such equal parts taken is called the numerator. I repeat, denominator means what? The total number of equal parts a whole is divided into is called denominator, and the number of such equal parts taken is called the numerator. And what we have learned else? We have learned about like fractions. So what are the like fractions? To whom we can say these are the like fractions? Fractions that have the same denominator are called like fractions. Means there are different types of fractions. Of that fractions, those denominators are same. They all are called like fractions. See, for example, 1 upon 8, 2 upon 8, 5 upon 8, 6 upon 8. In these fractions, each and every fraction is having the same denominator, that is 8. So these all are called like fractions. Then we have learned about unlike fractions. So what is the meaning of unlike fractions? To whom we can say that fractions are the unlike fractions? See, fractions that have different denominators are called unlike fractions. Like fractions means what we have learned? The fractions which are having same denominators are called like fractions. And unlike fractions means what? Fractions that have different denominators. For example, 1 upon 2, 2 upon 3, 4 upon 5, 8 upon 9. See, in this every fractions, there are different denominators. In the first one, we have 2. In the second fraction, 2 upon 3, we have 3 as a denominator. In third fraction, that is 4 upon 5, we have 5 as a denominator. That means every fraction is having different denominators. So all these fractions are called unlike fractions. What else we have learned? We have learned how to compare the like fractions. That means comparison of the like fractions. To whom we can compare? To which fractions we can do the comparison? Those fractions which are having same denominators. Same denominators means those are like fractions. See, for example, here we have 2 upon 3 and 1 upon 3. Now they both are having the same denominator. In first fraction we have 2 as a numerator, and in the second fraction we have 1 as the numerator. So we know 2 is the bigger than the 1. So here 2 upon 3 is the fraction which is greater than 1 upon 3. So here we have given the greater than sign to 2 upon 3. Let's say another example. 4 upon 10 and 8 upon 10. Here also we have same denominator. So both are the like fractions. So here we are going to compare with numerator only. So first fraction we have 4 and another fraction we have 8. So we know that 8 is the bigger one than the 4. So the second fraction, that is 8 upon 10, is the bigger fraction than the 4 upon 10. Now we know all these things like fractions, unlike fractions, comparison of like fractions. And what else we are going to learn? The new concept that we are today going to learn about See, addition and subtraction of like fractions. Addition and subtractions of like fractions. So let's see that one. Okay, now I'm going to on my camera. Just a moment. Okay, now I'm going to draw one shape on the board. See. Now I have pink chalk in my hand and I am going to color the part. Okay, first of all tell me how many parts I have distributed of this shape. Yes, anyone?
Six. Six.
Very good.
Six.
I have done, yes, I
Six.
have done 6 parts of the given shape. And of how many parts I have colored with pink?
One.
1. Very good.
One.
Very good. Now I have, yes, I
Four.
have
Shall
now
I
blue
tell?
color. See, I have now blue color in my hand. And I am going to color another part. Now tell me how many parts I have color over here?
Two. Two.
Correct.
Two parts
Now,
color.
okay, now my another question is, I have now pink one. With pink color, how many parts I have color?
One. One.
And with blue color?
Two.
Very good.
Two.
2. Now tell me, we have the total parts. Total of
Six.
shaded parts.
Six.
Six
Six.
we have. So
Six.
now tell me the
Six.
fraction that indicate the pink shaded part.
One upon six. One upon six.
Very
One upon six.
good. Now,
One upon six.
good. Now the
Two
next
upon
one.
six.
Good.
Two upon six.
Very good. Now, my
Two upon six.
okay. Now see my question. From the given figure, find out how many total shaded parts are there. So if they have asked about total, that means you have to do the addition. So for that, first of all, I need the pink part. How many pink fraction is there? That is 1 upon 6.
One.
Okay. And we
One.
have blue, that is 2
One.
upon 6. Listen me carefully. And here we have to do the addition. 1 upon 6 plus 2 upon 6. Now we have to do the addition.
Three upon six.
While doing the
Three upon
addition,
six.
see, mute yourself everybody. While doing the addition is taken part of the numerators only. So here 1 plus 2 upon 6. Now tell me what will be the answer we have get.
Three upon six. Three upon
Very
six.
good. 3
Three upon six, ma'am. Three upon
that,
six, ma'am.
yes, good. That means we get
Three
one
upon
here.
six.
Shaded parts we have color. That is the fraction of 3 upon 6. Okay, from these, can we find out how many unshaded parts are there? Yes, no?
Three. Three.
First tell me yes or no.
Three.
Yes or no.
Three parts.
Listen
Six
me.
upon six parts, ma'am. Three parts.
See, you are not listening my
Three.
question. You
Six
are
upon six minus three upon six.
listen my question. Mute yourself everybody.
Six upon six minus.
Now, to find out unshaded part. Now we have to find out the unshaded part. You should listen my question very first, huh? To find out unshaded parts, what I come to know, how many total parts are there? Yes, anyone? How many total parts are there? 6. So what will be the fraction for
Six.
that? 6 upon 6. So we have whole, that is 6 upon 6. Now to find out this one, what we are going to do? We need the total shaded part, that is 3 upon 6, that we will take. So we have whole, that is 6 upon 6 minus we have 3 upon 6. Now while doing the addition, what we have done here? We have done numerator addition. Here also while doing the subtraction, we are going to use numerators only. So for that we are going to do 6 minus 3 upon the same denominator, that is 6. So here we get answer 6 minus 3, that is 3 upon 6. That means we have shaded part 3 upon 6 and unshaded part also 3 upon 6. Got it everybody? Reply? Yes, no?
Yes, ma'am.
Now let's solve
Yes,
some
ma'am.
Yes,
more
ma'am.
examples.
Yes,
Good.
ma'am.
Now let's solve some more examples. Okay. I will write some examples on the board and you are going to give me the answer. Okay. Now my first question is about addition. So my first question is 3 upon 8 plus 1 upon 8. Yes, 3 upon 8 plus 1 upon 8. So what will be the answer?
4 upon 8.
Good.
4
Very good.
upon 8. 4 upon 8.
4 upon 8.
4
Very
upon
good.
8.
Good. Now my next
Ma'am,
question.
4 upon 8.
Yes,
4
very
upon
good
8.
Simla. Very good Janvi. Good. Now my next question. 4
4 upon
upon
8.
see my next question everybody. 4 upon 15 plus 5 upon 15. Yes, reply.
9
9
upon
upon 15.
15.
9 upon 15. 9 upon
9
15.
upon 15.
Very
9
good.
upon
Very good.
15, ma'am.
Yes, yes, yes. Good. Good everybody. Now let's take the bigger
9
numbers.
upon 15.
Good. Now let's take the bigger numbers. Suppose I have taken 23. 23 upon 100. Okay. 23 upon 100 plus I have next 41 upon 100. Yes. Reply.
6 upon 100. 6
6
upon
upon
100.
100.
No.
64 upon 100.
100.
64 upon 100.
64 upon 100.
64 upon 100.
Good, good. Now let's solve some examples of subtraction.
64 upon 100.
Very good everyone. Now let's solve some examples about subtraction. Let me write one easy one. Okay. So we have 8 upon 12 minus 4 upon 12. Yes. What will be the answer? This one.
4 upon
4
12.
upon 12.
4 upon 12.
Good, good.
4 upon 12.
4 upon.
4 upon 12.
Good. Now let's take one more
4
example.
upon 12.
Let's take
4
bigger
upon
number.
12.
upon 12.
Okay, let's take one
4
bigger
upon
example.
12.
33 upon 37.
4 upon 12.
Now the next question, see everybody. 33 upon 37 minus 22 upon 37. Yes, reply. 33 upon 37.
11
Very
upon
good.
37.
11
11
upon
upon
37.
37. 11 upon 37.
Very good, Shaurya. Very good. Very good.
11
everybody.
upon 37.
11 upon 37.
Very good, Siddesh. Now, next example. 48 upon 80 minus 26 upon 80. Solve this one.
22 upon 80.
22
Yes,
upon
22 upon 80.
22 upon 80.
22 upon 80.
very good.
22 upon 80.
80.
22 upon 80.
Now,
22. 22 upon 18.
yes, now listen everybody. Here we have seen some examples of addition of like fractions and subtraction of like fractions. To understand this concept more, let's see one video. I will share my screen. I am showing you one video. Just watch that video and after that I will ask some questions to you. Okay, so be ready for that and mute yourself. First of all, mute yourself everybody. When I ask question, that time unmute yourself. Okay. Wait a minute. Okay. Okay, till then, still the video is getting time to open. Nyanata is there? Yes?
Yes, ma'am.
Okay. Give me two examples of like fractions. Yes, give me two examples of like fractions.
2 upon 5.
Ma'am, shall I give?
Okay, Atharva, are you there? Atharva?
Yes, ma'am.
Yes, beta. Tell me two examples of like fractions.
2 upon 6 and 3 upon 8.
See, I ask about like fraction.
Sorry, 2
Hmm.
upon 6 and
Ma'am,
3
shall I
upon
give?
6.
Yes, Atharva, repeat again.
Ma'am, shall I give?
Okay,
2
Harshavardhan.
upon 6 and 3 upon 6.
Very good, good. Okay, now Harshavardhan, you are going to tell me about unlike fraction. Two examples, that is of unlike fractions. Yes. Yes, Supekar. Harshavardhan Supekar. Yes, beta. Just a minute, that video is getting off. I will open that one again.
He is
Share my
not
screen.
there.
He is not there. Okay, no problem. Then who's there? Akanksha?
Ma'am, shall I give?
Yes, Vedant. Vedant? Yes, beta.
Ma'am, 3 upon 6 and 2 upon 4.
Good, very good. Okay, now orally we will solve two examples of addition. Okay? So first we have the question, that is 5 upon 12. Listen my question carefully, huh? And in the chat you are going to reply me now. Okay, mute everybody. Samiksha, mute yourself, beta. Okay, because sound is echo coming, no? So here what you are going to do? You are going to do the addition. Whatever numbers I am going to tell, you are going to do the addition of that. Okay? So here we have 5 upon 12. Okay? 5 upon 12 plus 4 upon 12. Yes, tell me the answer in the chat. Yes.
Ma'am,
Yes, Arnavi, repeat.
5 upon 12 and ma'am, next.
4 upon 12, beta. 4 upon 12, yes. Okay, now who's going to tell me orally? Arnavi, can you try to give answer?
9 upon 12.
Good.
9 upon 12.
Okay. Now another example of subtraction. Okay, another example of subtraction. Okay. Write it down, the example in your notebook. Okay, write down 12 upon 28. 12 upon 28 minus 5 upon 28. 12 upon 28 minus 5 upon 28.
Ma'am, 7 upon 20.
Yes.
Ma'am, 6 upon 28.
No, 6 not.
7
7 upon 28.
7 upon 28. Okay,
7
now,
upon 28.
yes. Now let's see the video.
7
See
upon
everybody.
28.
Yes, 7 upon 28. Correct. Now let's see the video. Then I will ask
Look,
again.
it's Raghu and Hari. They already know how to add and subtract whole numbers on the number line, and so do we. In this lesson, we will learn how to add and subtract fractions on the number line. Let's first understand addition of fractions with the help of this example. We start by locating the given fractions on the number line. Raghu and Hari are going to help us do that. As the denominator in both these fractions is 6, we divide the portion between 0 and 1 into 6 equal parts. Now, in order to locate 2 by 6 on the number line, Raghu hops across 2 of these 6 equal parts. starting from 0. Similarly, to locate the fraction 3 by 6, Hari hops to cover 3 of the 6 equal parts. Look! Now, let's add the distances they covered on their number lines to find the sum of 2 by 6 and 3 by 6. The resulting fraction is 5 by 6. We get the same sum even if we change the order of addition. The same addition could have also been done on a single number line. We know that every part here represents one of the 6 equal parts. Hence, each of these equal parts is 1 by 6. Now, in order to represent 2 by 6 or 2 parts of 6, Raghu hops across 2 of these equal parts, starting from 0. And to add 3 by 6 to 2 by 6, he simply hops across another 3 parts, starting from his position at 2 by 6. Thus, Raghu reaches the required sum, that is 5 by 6. Now, let's see how Hari adds these fractions. 5 being the denominators here, we divide the portion between 0 and 1 into 5 equal parts. Each part represents 1 by 5 of the distance between 0 and 1. Hari hops forward across 3 of these equal parts, starting from 0, and reaches 3 by 5 on the number line.
Okay, what will be the answer? 3 upon 5 plus 1 upon 5.
Upon 5. 8 upon 5.
4 upon 5.
5.
Okay, let's
8 upon 5. 5.
Okay,
4
okay.
upon 5.
Okay, now listen to me. Let's solve one quiz.
4 upon 5.
Let's solve one quiz. Now here we have 11 upon 100 plus 77 upon 100. What will be the answer?
88 upon 100. B.
Very good.
B.
88 upon 100.
88 upon 100.
Yes.
88 upon 100.
Good. Next.
upon 100.
Okay, next question. Which fraction shows the sum of both shaded areas, means yellow also and blue also? First you have to see the total parts and then count the shaded one. What will be the answer?
13 upon 16. 13 upon 16. 13 upon
Okay.
16.
Okay.
13 upon 16.
Okay.
13 upon 16.
Correct.
Yes,
correct,
ma'am.
Correct. Next, do the subtraction. 16 upon 17 minus 7 upon 17. Yes, 16 upon 17 minus 7 upon 17.
8 upon 17. 8 upon 17.
See the answer, the options.
23 upon 31. 9 upon 17. 23 upon 31.
See here we have to do the subtraction.
23 upon 31.
No. How the denominator will change? Yes, Samiksha. Samiksha, you answer.
8 upon 17.
Okay. Yes, correct. So like this, we can solve the different types of addition and subtraction over here. Okay. So now what you are going to do? You are going to take any 4 or 5 like fractions and then you are going to do the addition and subtraction of that fractions for your self-study. Means as a practice, you are going to solve some examples of like fractions and some examples of unlike fractions for self-study. Okay, now from these, do you have any query? Do you want to ask any question how to do addition or how to do subtraction? Is anybody having any query on this? yes. If no,
No,
yes.
ma'am. No, ma'am. No, ma'am.
Okay. So now here,
No,
yes,
ma'am.
good, good.
No,
So
ma'am.
now what we have learned over here, how to do the addition and subtraction of the like fractions. Okay, means while doing the addition or doing the subtraction, we are going to use the numerators. Okay, only numerators addition and subtraction can be done when the denominators are the same. Okay, when the denominators are same means that fractions should be like fractions. Then and then only we can do the addition or we can do the subtraction. Okay, now as I told, you are going to take any 4 or 5 examples for your self study. So as a revision, solve some more examples at home. Okay, now here till then say I'm going to stop my meeting here. So everybody have a nice day, good day, and stay safe, stay healthy at home. Okay, bye everyone.
Bye bye, ma'am.
Bye bye,
Bye
ma'am.
bye,
Bye
ma'am.
bye.
Bye bye, ma'am. Take
Bye
care.
bye.
Bye
Yes,
bye.
you do take care, beta. Yes, I'm going to
Bye
end
bye,
this
ma'am.
meeting. Okay, bye everybody. Stay safe, stay healthy.
Bye, ma'am.
Bye.
Bye, ma'am. Bye bye, ma'am.
Bye.